So thank you.
Switching
myself as the presenter. Can you see my screen?
Yes.
Yes.
Yes. All right. We are go. Thank you for joining the very official and formal MIST Systems webinar. Much appreciate you being here. And today we will be talking about advanced Wi-Fi. We'll be talking about API scripting, automation, location tracking, and all of this from a very practical perspective. We have partners who have made their own applications on top of the MIST API. We have other partners who are true geniuses in automation and building, Wi-Fi in different difficult places. We have examples of building Python scripts around the MIST system, and we have plenty of real-world tried and true location stuff here today as well. Thank you for joining, everybody. Now, if somebody could try that both the chat board works and the questions board works, that would be amazing. I'm not sure if we have on the audience, do we have Ilpo and or Tommy promoted as the organizers, Tommy, or if not, could we do that? Because I know we have people on the line. Perfect.
I'm on it.
We have people on the line who will be answering your questions as well. So anything you have, Wi-Fi related, MIST related, software development related, send them over. We sure as heck have got them. So I'm just promoting Tommy Järventie now as an organizer here. Tommy Järventie, can you hear me?
Thanks, Jussi.
Thank you, Tommy. So thank you for joining the webinar, and you will be on the back end answering the questions at the chat board, correct? I guess.
Not sure if Tommy hears, but we will make sure. Ilpo here.
Yeah.
We will make sure that the questions get answered.
Cool.
Yeah.
Okay, absolutely. And we already got some test questions here. So please send those questions, keep them coming. All right, today, this is the agenda. We'll talk about Wi-Fi, PLE, maybe a little bit of ultra-wideband location tracking and the way they differ. So in the real world, what's the performance of each? Josef will talk about weird Wi-Fi, weird. It's not pronounced weird, it's pronounced weird. So that's something. I have no idea what it's going to be. A couple of days ago, he was like, do you want slides or do you want conversational? And my response was, whatever.
Keep it weird.
Yeah, just keep it weird. So and then Jonas is from Complete and Wi-Flex, and you will be talking about like how you guys actually as a MIST partner have created applications and deliver marketing tools as well as valuable enterprise tools for your customers, right?
Yes, that's correct. We will show some awesome tools. So.
Excellent. And now we also have, going back to the RTLS location stuff, we have Matt Sterling also on the line. Hey, Matt.
Hey, mate.
How goes?
Can you hear me?
We can.
Yeah.
Can you hear us?
Okay, cool. Yeah, I can hear you. Apologies if my audio and visual isn't great. I'm actually on site for a customer, so just joined from somewhere in the office quickly.
Gotta hand it out to you, man. You're at the customer site, and yet still you could spend some time with us on the webinar. Thank you so much for joining as well.
Pleasure to be here.
And you guys will be first up, so that we can let you go, whenever you guys are done. And Francois, thank you for joining as well. Python APIs and automation. Anything we should do to prepare today for your show?
Not sure. Get your brains ready, I guess.
Your brains ready. That's what I'm talking about. All right. Hey, just a reminder, or like this is what happened yesterday. Anybody want to guess what this picture riddle is all about?
There's an AP trying to go above the hurdle.
Exactly.
I don't know
What
what
could
that
this
is.
be? You don't?
Um,
Boot camp. It's a missed boot camp.
oh, okay, I get it now. It's like an army boot camp type of thing.
So what did you guys think? We were just, before we started, we were talking about the missed boot camp, which happened yesterday.
It was good.
awesome.
A lot of good presentations, a lot of good demos. And I believe the videos will be available, right? So people can go back and watch the presentations. Some
Absolutely,
stuff.
absolutely. So for those of you who don't know, yesterday we had a Mist, like these events are big, but Mist had its biggest ever event yesterday online, and it was like 6 hours, 5 or 6 hours of non-stop technical presentations, roughly 20 minutes each. Josef, what did you think?
Oh, it was actually mind-blowing, and I can say that now. I couldn't sleep last night. I needed to sort all this information in my head before I went to bed, and it was really, really mind-blowing. The fact is, so far I thought I know Mist, but let me tell you that, guys, this beautiful GUI, don't let that fool you. It just really has a lot of powerful tools under the hood. So I need to go back to studying and learning and going and reading the documentation again. It was really, really, really fantastic.
So Matt, did you make it to the event? You did, right?
I didn't make it to the event, but I saw all of the. I felt like I was there from everything I was seeing on Twitter. Everyone's, especially Francois, you know, he's keeping everyone updated, everything that was going on. I felt like I was there. Unfortunately, I was in and out of doing some work, so I couldn't actually join. But looked like it was a good event, and it seems like a lot of people started to see and learn about how good really the Mist platform really is.
Excellent. I will send on the chat board my email address. So if you want the recordings, the second they come out, just either Google Mist Bootcamp Wi-Fi and you will probably find it, or just email me here. And I'll make sure to send you the recording links as well. That's now on the chat board. Jonas, did you happen to watch the bootcamp?
I've watched a few presentations about it. It was amazing. The flexibility of Mist is very good. I like the API approach and the open environment. Yes, I really like what I've seen. So I'm curious to test all the features. Also the switch configuration and all that kind of stuff. So yes.
Yeah, the switch configuration will be fully on the Mist UI as well, and we talked about that on the bootcamp, and that's pretty exciting. Anybody, did you, before we actually start the show, what was the #1 lesson or thing you didn't know before that you learned during the bootcamp? Was there anything like that for any of you? Josef, what do you think?
Deployment, because we just finished a big project deployment with other vendor, unfortunately, but lesson learned, it's really easy to do that when you have API ready to support you in that, rather than trying to build all these kind of automation by yourself, by your team. So I kind of knew that before, but I didn't know how simple that is, especially this integration with Ekahau, changing access point names and stuff like this. It's so annoying to do it in day-to-day, and that was really, really good.
It's nice. Anybody else? Francois, what was the #1 thing for you that you maybe didn't know about Mist or that you really liked about the bootcamp?
I guess the #1 for me would be the when they showed the stats regarding Marvis and the number of tickets. So they showed a graph where you could see that in the last few months, the number of everything increased, number of sites, organization, devices out there increased, but the number of tickets in the support backend supported by the AI stayed the same. So it's just showing you how the machine learning is actually learning, right? Something, and how the AI is getting better day after day. That's kind of like what I like about Mist. Like from the very beginning, they put AI in the center of it, and For me, like when AI was never really a buzzword with Mist, because they showed you everything from the get-go. So they showed you what, you know, what didn't work and how the algorithm is learning. So it's not perfect yet, right? But it's definitely improving. Yeah, it's definitely improving. And then I guess all the switch info, all the data you can get from the switches were pretty cool. Like, you know, the cable testing and all of that integrated in Marvis was pretty cool to see.
Absolutely. So, hey, if we had to do a 10 seconds intro of each person before we go on, I don't want to keep people waiting for too long. I'm Jussi, I work for Mist, I do all kinds of janitorial duties, and I like old computers. Jonas.
I'm Jonas Dekkers, co-founder of Wayv. We are a Wi-Fi partner, do a lot of Wi-Fi projects, and we like to play with APIs and create cool stuff with it.
Cool. Thank you for joining, Jonas, again. What about this handsome chap right here?
I would have to too.
Oh, I remember when you took that picture from WLPC. I haven't actually, don't think I've seen it though. Yeah, so I am a co-host of the Wi-Fi Ninjas podcast with Mac Daring, and I work for Nordic in the UK.
Absolutely. Wi-Fi-ninjas.net. And is Mac? Do we have Mac?
Yep, I'm here. It just the
video
doesn't work.
Oh, okay. So you're not on video, but you're here.
I'm trying. I've restarted everything I could, but the video just won't show up.
Don't worry about it. GoToWebinar is notoriously bad on that, and I apologize for us.
You're doing everyone a favor without the video anyway, mate.
Especially like it's in 4K, so you wouldn't like to see my face in 4K.
The best thing I ever seen is Mac's face live. 4K doesn't do it justice. It doesn't begin to cover your handsomeness, man. So who are you? What do you do?
I'm a Wi-Fi ninja. I really like Wi-Fi. Even I'm dreaming about Wi-Fi. Like honestly, when I'm getting into the dreaming stage of my sleep, I wake up and I think about Wi-Fi. It's happening to me like for the last several weeks, working on so much Wi-Fi content. And yeah, we are working together with Matt at Nazilic and enjoying every second of my career in the Wi-Fi world.
Excellent. Thank you so much for joining, Mac. Pleasure having you here. Just like it was pleasure having you on the picture tinkering, with ultra wideband back in our Helsinki office.
That was
what
amazing.
About this guy? This guy is a repeat offender, as we call them here in the Mist webinar.
Yeah, so my name is Francois. I'm the co-host of the Clear Sun podcast with Roel. If you guys like Wi-Fi, you should listen to the podcast. We publish every week. And we have a lot of fun doing it. I'm also the owner of Semfio, so it's a company based out of Canada, and I just work as a Wi-Fi engineer. I love Wi-Fi, and I'm also a big football fan or soccer fan, depending on where you live.
And you really like Ajax, Amsterdam Ajax, right? That's your favorite team, or is it? So.
Mine?
Yeah.
Are you talking about my club?
Yeah.
My club is a small club in France, my hometown, Dijon. So it's not very interesting for everyone. Yeah. It's not as interesting as the Ajax, for sure.
I was just teasing you. Well, welcome to the show. Thank you for coming on again, Francois. And this guy, though, looks like he's from an old painting. And this is without filters. God's honest truth, isn't it, Josef? This has no filters whatsoever. The place just looked like that. I have
I'm just naturally blonde. You don't see that in that picture, but that's a very, very natural picture. Actually, it was a really nice evening. So yeah, I'm Yosef Graziano. I'm a co-founder of Wayv Systems. We are based in Germany with Sebastian Tubis. And we are also Wi-Fi people. We are Wi-Fi geeks, we call ourselves. But we are also business people, and our company actually is offering end-to-end solution of Wi-Fi. In general, wireless, but we focus on Wi-Fi.
Perfect. And today you will cover weird Wi-Fi, correct?
There's a lot of that.
Sounds perfect. So hey, let's get on with the show. So Wi-Fi Ninjas, should you guys take it away, and then we'll go from there to Josef, Jonas, and Francois. So Ninjas, and the topic is RTLS Showdown. What do you got for us?
Okay, so we've got quite a lot of RTLS stuff, especially around the MIST BLE. And at the end, we have like a special insert about ultra-wideband that we will try to cover in 121 seconds. So challenge accepted. Nice. It was your idea, Jussi, and we had to stream it down a little bit, but we are ready to go. So let's start with sharing my screen. How do I do that? Do you have to make me a presenter?
Yes, I will make you the organizer. So when you leave the webinar, if you're an organizer, please don't end the webinar if you leave early. You should be the organizer.
There we go.
I gave one of the Mac Daring's organizer rights.
Nice name, Matt.
Your link to join is it's put me in as Mac Daring, but since you joined as Matt Starling on the WLA, I thought it was quite fitting, you know, to join as you today.
Okay, guys, can you see my screen?
We can, and let me close my door real quickly, but go ahead, Mac, and begin.
Okay, I'm going into presentation mode. So, hi guys, I'm Mac. I like Wi-Fi. We are Wi-Fi ninjas. And this is Matt. He's just like skipped his slide. So Matt
I can't actually see your screen. I can just see the guys, and like I can see your desktop. Unless it's being really slow. It's just being slow. Ignore me. I think I'm using the guest SSID on a customer site, so my Wi-Fi is probably not the best here.
It's definitely not a MIST network, is it, there at your customer?
No, it's not. It's definitely not.
Sorry, man.
I will crack on then.
But yeah, you're good. You're good, Mac, at least for me.
So thank you very much, Jussi, our favorite beacon, for inviting us here. And this is like, you know, a co-founder of the beautiful mounting bracket for the RTLS ultra-wideband solution that we have, like, you know, worked on together with Jussi when I visited Finland a few months back before the lockdown. And this is like the version 2 of the mounting bracket that me and Matt have put together to, you know, to mount our wireless anchors even more efficiently. So we've learned a lot. Thanks a lot, Jussi, for sharing your DIY knowledge. It was a massive experience for everyone involved. So let's start with the RTLS components. So first of all, what is the RTLS? So RTLS is the location services, especially indoor, where the GPS cannot be used to match. And with RTLS, we have location sensors that are installed fixed around the building. We have tags, and tag can be a device. It can be, you know, a person carrying a tag. It can be a mobile phone. And everything around RTLS is around locating this tag with a use of location sensors. And then we have location engine that calculates this location for us. And then we have a location system that visualizes all the location data for us. We can also have a middleware that is very often a part of the location system to just aggregate the data, location data, from multiple RTLS solutions. That's it: tag, mobile, location sensor, fixed, and some infrastructure. Positioning models is a very, very important topic to discuss. So there are 3. First, and most widely used today, is a server-based positioning. This is a scenario where a tag sends a beacon that is being picked up by location sensors, and then location sensors, they send over the data from the blink from a tag to the location engine. It can be anything. It can be the RSSI, it can be the timestamp, it can be the strength of the audio received from an audio tag in some RTLS solutions. So it depends on the physical underlying technology and ranging technique when it comes to the data that is sent to the location engine. And then location engine, it calculates the XY or sometimes XYZ coordinates, and it sends it over to the location system for visualization and for further analysis. Then we have a client-based positioning. So it's a little bit different because now it's not the tag that sends the beacons, it's the location sensors that they send some transmission that tag is picking up. It knows the location of the sensors, and based on the received information, it can calculate its own location. Okay, so when tag calculates its own location, it can use it for wayfinding, for indoor wayfinding. It can use it for like a panic buttons. The use cases are quite unlimited in this case. But after calculating its own position, it can send the position calculated over a normally wireless back channel to the location system for further analysis. And then we have mixed server client based positioning. So in this scenario, we have location sensors that are sending some transmission. It can be an RF transmission, it can be audio, it can be visual. In this case, let's assume that it's an RF thing, so like an RSSI or time. The tag is receiving this transmission from multiple location sensors, but this time it doesn't calculate its own position. Sorry, it sends the readings from location sensors to the location engine that can be put in the cloud or on-premise, depending on the vendor and solution. And then location engine, based on the information received from the tag, calculates the X, Y, Z coordinates, and it sends it back to the tag. So tag can use it for, let's say, blue dot experience, wayfinding, etc. And also it can send the same calculated information to the location system for us to see, to visualize, to work with. And MIST is a perfect example of this mixed client-server based positioning. So that's exactly what we do here. Try to imagine that you have an access points from MIST, and you have a phone. All the access points from MIST, they are sending BLE beacons that the phone listens to, and then the phone sends those beacons data. Like, I've heard so many access points with so many beams, IDs, it sends it to the MIST cloud. MIST cloud does the calculation of the client, and it sends it back, the calculated XY coordinates, back to the phone or to the tag. So it can be used for some juicy RTLS functionality. This is actually a very smart solution from MIST. So normally RTLS, to have this level of accuracy of around 1 meter, sometimes 2 meters, sometimes less, it's using some very advanced ranging techniques like angle of arrival, where you can position clients in 3D with quite high accuracy, or time difference of arrival with a few centimeters accuracy. We don't do that here. We have just the old good RSSI, but what we have instead, we have 8 directional antennas, BLE antennas, around the access point, and they are sending the beacons all around. And then when the client picks up those beacons, one beacon from the directional antenna that is directed towards the client will be strongest, okay? And then the client will send back these readings to the MIST cloud for calculation of its location. And based on that, the cloud can calculate the location quite nicely and accurately, and most importantly, very quickly. Sub-second is the frequency of a location calculation with MIST. So well done, guys, on that. This is the only vendor on the market that we are aware of that does things this way. And it's another very juicy thing from MIST is, like, there are no two devices that are similar or identical. They have different antennas, they have different sensitivities. So even if you have 2 different devices in a single place, they will hear the beacons from the access points with different RSSIs, right? So what MIST does, it uses some machine learning to adjust the variance of every device type in the network. Every access point will apply some filters, some adjustments to every device type, and all we need to do is just walk around, and this variance parameter will be applied automatically for us, so we don't have to do anything. The more we walk around in the environment, even if it's a dynamic environment, the more accurate the location calculation will be for us, which is amazing. So no manual, how do you call it? Fingerprinting of a network.
Yeah, no
calibration.
Yes,
Yeah.
calibration.
Yeah.
This is like unsupervised machine learning at work. So you don't need to supervise the system in any way. It just learns the differences of different devices based on the fact that, people naturally with their phones, they walk around the site, and it automatically calibrates itself.
You don't have to walk too much. It's like, after 2 minutes of walking around, the device is profiled, and it's getting as good as it's going to be. And here on this show, you can see few missed access points, and you can see like, you know, eight places around the access point where the RSSI readings are displayed. And you can see the device walking around, like moving around, and different access points in the location cells of where the device is, they are showing the readings of the RSSI of what the device seen when it received those beacons from directional antennas from missed access points. And that's how system sees it. And it's quite mind-blowing, actually.
And it's like this compensates a little bit for the fact that you need a boat ton of Wi-Fi access points, for example, to provide good accuracy with Wi-Fi. But having these arrays on each of the access point gives us, you know, 3, 4, 5 times more signals every time they scan. They don't get every scan, like not every antenna picks it up every time, but even if you get 3 or 4 or 5 times more signals every time, that makes the location accuracy so much better.
And faster at the same time.
Absolutely, yeah.
Tip number 1, when you design for missed RTLS, because like, you know, missed is using BLE, but it's not just based on proximity. So there are some good tips that we'll share. First of all, you should mount the access point horizontally and face down. And very importantly, we need to note the azimuth, the location that the access point is pointing towards. So note the LED orientation. We will need that later on while putting this into the missed system. Tip number 2 is to stick to the square design in open spaces and zigzag design in narrow spaces. And also we have to ensure to cover the transition areas. And a quite important tip around this is that we don't want to put the access points in the very corners of the rooms. We want to put them slightly, you know, farther away from the corners to make sure that the people really can walk around the access point and not only towards the, you know, corner of the room where the access point is. So it's a little bit different to what you would have designed for when you were designing for the RSSI lateration-based Wi-Fi RTLS. We'll show you some examples on the next slides. So theoretically, a mist can work with one access point per location area to just give us like an estimated position of a client, which direction it's coming from. 2 access points, however, I would say it's a minimum for a reasonable accuracy. 3 access points will give us a good results. We were doing quite a lot of tests with 3 access points, very successful tests, but 4 access points will give us a very nice error correction where the accuracy will be better. And in the live environment, where we have quite a lot of access points around, hopefully more than 3 or 4, it will be even better. Number 4 is that we have to ensure that the line of sight is maintained between the access points and our clients. So we cannot put access points behind the ceiling tiles. We cannot, like, you know, hide them. They should all be on the same height, if possible, in the same location cell.
Just to build on that statement, however, it does not mean that, you know, there should be nothing ever between the tracked object and the AP. Definitely not. So there can be walls between those and stuff like that. But
Correct.
the better the line of sight, and yeah, I guess the point is don't put them in the false ceiling at least. You know, don't do.
Even on your website, you have shown some designs where the access points were put behind the wooden architectural thingy, good-looking ceiling that is not like solid wood. It was like wooden planks, and it still worked fine. And we were testing the RTLS from mist through dry walls, and it was fine as well. So it's not like set in stone, but it's just a best practice. And when we design for the frequency of how frequently we put the access points in our floor plan, 8 to 15 meters seems to be reasonable, and we can slightly relax it in the corridors, which you will see in the design examples. And also access points, they should not be mounted too high. So 2.5 to 4.5 meters is perfect. Will it work when you put it slightly higher up? It will, but the higher we put it, the less directionality we'll have from the arrays, from the access points. And we were testing it as well. When we were having access points on 2.5 meters, it was very, very good. But then we had a chance to put the access point on, like, 4 meters when we were testing it with Fernie in the hotel. And I don't think it was as accurate when we used the highest available setup on our tripod. So slightly closer to clients tends to work better. So this is like a design example number one, location for design for location with Mist. So first of all, you can see that you have the access points kind of on the outside perimeter of the building. So look at the meeting rooms. The access points, they are in the middle of the meeting room. They are not in the very corner. This will give us slightly better accuracy when you are, around the access point, because it will know which side of the access point your client is actually in. Then when you have the outside perimeter covered, we will add some more access points, so more black dots in the center that we require for capacity. And that's fine. It's like, the access points, they would be there anyway. And then the blue dots, these are more for the accuracy and for transition areas. So that's where people will be walking, through those areas, and we need to have access points there to help us out with more accurate location calculation. So this is just a standard.
Do you use APs or do you use the beacon, the BLE?
We can use both. Like for the blue dots here, normally when we don't need more capacity, we would normally put BT11 BLE only access points that that you can connect and daisy chain from the main Mist AP that has both Wi-Fi and BLE radios built in. So BT11s and 41s and AP43s, they have similar BLE arrays around them. And for the RTLS, it's no difference really between BT11 and, let's say, AP41.
So just real quickly on that to emphasize, so there's access points. All of the Mist APs have the BLE array that you just presented, but then there's a device, lightweight, smaller, cheaper device that only has the BLE array, but it doesn't have Wi-Fi. And then thirdly, there's also the option, isn't there, of using just beacons, like standard, these battery-powered beacons. You probably don't want to use them unless you have to. But let's say you have a scenario where you just can't place anything with a wire in some places. You can actually augment the location system using just any standard BLE beacon, right?
Yeah, correct. That's assuming that your device is listening for those beacons. So when we have this, mixed positioning model, then the beacons would certainly help. Okay, example number 2. So here you can clearly see the rectangular design in open spaces of this, convention. I don't know what it was. It was some kind of an event. But then in the corridors, you can see the zigzag location, zigzag placement of the access points. If you want to have square placement of the access points here, we would have had to use way more access points. And this is more than enough. And also we will have probably wayfinding paths. We'll talk about it later in a sec, actually. But you don't tend to walk in a zigzag pattern when you walk through the corridor. You just will walk through the center of the corridor, and we will just draw the nice straight line, which your device, your blue dot on the screen, will be snapped into to make it appear even more accurate than it really is, which is quite nice. Okay, so now just to discuss the difference between the components required for Wi-Fi RTLS versus Mist BLE RTLS. To make sure that we are comparing apples to apples, we will be referring to the hyperlocation because it gives us similar accuracy to, theoretically, of course, to Mist BLE. And there are normally mostly widely used RTLS solutions with Wi-Fi. They are based on the RSSI, not angle of arrival, and they are different. They don't give us this accuracy of 1 to 3 meters. They give us accuracy of 10 to 15 meters sometimes. So this is around the hyperlocation. So what do we need? We need access points with antenna, more than one, a lot more. And those access points, they tend to be quite big, okay? And then we need to have wireless LAN controllers, preferably 2 for redundancy. And we need to have maps services server to upload maps, to scale them, to put the walls in if you want to put an access point in, and then we will export those maps to data crunching location engine. In most cases, it will be 2 servers. And then if you want to view this data in understandable way, we probably will have some front-end system, location system that we can, analyze data further and make business decisions based on what we see. And also, if you want to make it even more accurate, we might add some beacons. So that's a lot of components, right, to make it work. It does work, but it's slightly on the complicated side. Now for a comparison, this is what we need for Mist. We need access points that have access to the internet to be able to talk to Mist dashboard. That's it. There is nothing else. Absolutely nothing else. I've skipped like the wired networking side. So of course you need to have POE on both examples, but this is as simple as it gets. And it's lovely that it's so simple. We've done it more than once now with Matt. We've deployed some Mist RTLS, and in most cases we are done before lunchtime, which is amazing.
Yeah, and the first time we ever very first touch Mist as well, we'd never played around with it, and we got sent some pot kit to set up in your house within, I think, the first hour of receiving the Mist APs. We had everything up and running, and we was running around your house testing. So I think that just goes to show how simple it is to get Mist up and working for someone that's never even used it before.
Yeah, exactly. It's so simple. It's a pleasure and a blast to work with, really, for everyone. Okay. And did we mention daisy chaining of BT11s? I think we did. So we can daisy chain up to 4. So off a single PoE port from a switch, you can connect to it an access point like AP41 or AP43 or an external one. And if the access point has the PoE pass-through port, you can connect up to 4 BT11s to it. Isn't it amazing to just use, one port instead of 5?
Hey, hold on, just to clarify that in the name of honesty. So to an AP's port, I think you can put 1, right? But to an AT switch port, so that provides AT power, you can put 4. Just so that we are correct on the terminology. Behind an AP, 1 BT11. For an AT PoE port, you can put 4. I think that's the deal, right? That's what you were saying, but I just wanted to be sure that,
Of course, and also Jussi has mentioned that we have BLE arrays built into every access point. That's including outer and external ones, which again, it's quite amazing because we are putting, some access points very often outside as well, in parking areas, where the lorries are, or, we have some external access points in places like zoos and this kind of, public spaces. It's amazing to have it because we are using it quite frequently. I know that you can use GPS, but sometimes the use case requires you to have, consistency throughout your RTLS system within an application. So it's great to have. And that's the demo time. So this is our setup. We've been doing some tests in my house with Matt. We had 3 access points here, so not even 4 that are great for error correction. So this is not a perfect solution. It's workable. The access points also, they are not as far as they should be from one another. So we should have the access points like 8 meters apart. And we have them like maybe, this is 8 meters, but this is not 8 meters. So like 5, 6, sometimes 8 meters. And they are 2.2 meters high, which is perfect. And that's what we had. This is the screenshot from the Mist dashboard where you can see everything that you really need. You just, set up a floor plan, you upload a floor plan, you can draw wayfinding paths. So these are the paths that you think your clients that you are tracking, your tags, will be taking. In example, when you have an aisle between 2 racks, you know that people, they won't go through the rack. They will always take the same path to go from one side of a rack to another side of a rack. So that's where you will put wayfinding paths to be snapped into. We also have beacons and zones, which we'll talk about while watching our beautiful video. And you have a scale tool. And you can, of course, draw some zones. We've named the zone like a kitchen and a meeting room. And when we walk around in this pattern here, you will see that we are switching between those zones. You can capture those events. You can export them live using APIs to your RTLS location system. It doesn't have to be, demo Mist app. It can be incorporated into the mobile application of your choice, your corporate mobile application. So it's possible. And this is a short video from our tests. So what we can see here is Mr. Matt Starling walking calmly around a beautiful wall of my unfinished floor. You can see his blue dots in the middle part of the screen, and that's a recording done on his phone. We can see that, his phone is using a compass, and we can see the compass readings on the application as well. And now what's happened? He has hit this orange circle. And the orange circle is the virtual beacon. By virtual beacon, we mean we didn't have to put a beacon, battery-operated beacon there for this, browser alert to happen. We've just specified it in the system. If he comes into this area, please open a browser with a coffee.brew. And Matt is continuing his journey along the blue wayfinding path. When he gets to the corner where there is another browser alert virtual BLE action specified, a little bit smaller, and it has opened really nice website, wifininjas.net. And that's it. It was like very fast. It was very accurate. And most of all, it didn't require any specialized equipment. It was just standard client, serving missed access points. It was just standard phone, no servers included, nothing. And that's sleek. You can also work on the animation of the dot, so you can make it animated nicely. You can use more sensors from your phone, like a gyro. You can use accelerometer. You can use compass to expect like the direction of movement of a tag. So it doesn't have to be jumping every second. It can be super smooth. Bear in mind that if you're using a GPS, it's also not super smooth normally. The smooth movement of your dot is built into your application. So GPS normally calculation happens on your phone or on your GPS device every 1/3 of a second, every 1/2 of a second, or every second, depending on the battery saving mode. So it's also not constantly, calculated. It's the same here. And we think it was mind-blowing. Is there anything you want to add, Matt, to our test results?
No, just the fact of how simple it was to get all set up and running compared to some of the other location deployments we've done, and how many servers and boxes we have to put in, and then even comparing the accuracy from Wi-Fi to BLE was pretty phenomenal. So yeah, it's really blown away of how simple and how accurate Mist was, and that's why we kind of prefer to deploy Mist now for these locations.
You have to believe, right?
Hey?
You have to see the Mist BLE in action to believe. Really,
yeah,
we've done a few more times with some people that have never seen it before. Like when we were attending some ECSE classes with Ferney, we put together a nice lab with 4 access points, and it was crazy amazing, simple and accurate. So yeah, we encourage you to arrange for a POC and take a look at it yourself.
Mike, I have a question.
Yes, sir.
Which application did you use on? I guess Matt, which application did you use on your phone to showcase the blue dot?
So this is just the Mist app from the Apple Store. They have a mobile SDK app you can just download, and then you can sync it to your organization, and it pulls the floor plan down, and you can just get going straight away. It didn't take any time at all to set up. I think if you go into the Apple Store and just search for Mist, it's one of the applications on there.
The same one that you would use to claim an AP, for instance? It's the same one, right?
No, it's a different one to that. I think they've got 3 apps on the App Store.
Okay.
I can't remember exactly which one is off my head, but maybe Jussi knows because he's talking, but I think he's on mute, so I can't hear him.
Like any good webinar host, I don't know how to use the mute, unmute. It's Mist AI and Mist Experience, I think, are the 2.
Okay, awesome. Thank you, guys. Thank you.
I also want to add something about the virtual beacons. If you have a changing environment like a museum or something, you can just schedule with APIs to replace the virtual beacons. For example, you have a museum and you have an exposition next week, and there are some things changing from place. You can just create an API script, and you can just replace all the beacons, so the pop-ups will be activated at other places. It's a really nice solution, the virtual beacon. So,
true, and you can specify action within the application, right? What happens when you hit the virtual beacon? It can be a notification, it can be like a new website, it can be any action within an app, which is amazing. And also the circle, the radius of the virtual beacon, it can be adjusted. It can be small, it can be big, it can be like as big as a room, it can be as small as just standing in front of some specific display.
Yeah, absolutely. That's the one. So if one was to, seek for advice, that kind of stuff. So in the UK, they could call, and Ireland, they could, reach out to the ninjas. In the DACH region, it would be Josef. Benelux, it would be Jonas. Francois in the US and Canada. Is that fair?
I'd like to mention that one big advantage of having the AP11 connected to a normal access point is actually reducing the need of extra cabling and extra infrastructure, which is one of the biggest, I think, one of the biggest points when you look at the environment where we work. Cost of installing cables in factories, it means also cost of stopping the production in order to install that cable and pull it back. So this is actually a really neat feature.
It's not only about cost, it's also about fun as well. Like working with Mist is fun, it works. So yeah, go on and try it yourself. Now let's move on to a very cool challenge. So challenge time. We will cover ultra-wideband theory in 111 seconds, okay? It will be difficult because it's not as quick, it's not as, simple and easy, but let's give it a go, okay? Go. Right. So ultra-wideband, it's not using RSSI, it's using time difference of arrival. So each location sensor will take a look at the blink time that that it has received from a tag, and then the location engine will use the time difference of arrival on this blink from a tag to calculate XY coordinates from the tag. And actually ultra-wideband is using trilateration, which means that it will draw circles around the location sensor, knowing the distance between a tag and the location sensor, and where the circles intersect, that's the location of a tag. And the accuracy is mad. It's up to a few centimeters. So that's where the ultra-wideband sits in the RTLS world. It has a very wide spectrum. It uses 5 megahertz wide channels. It's very silent when compared to modulated sine wave protocols like 802.11. And yeah, that's it. And this is like an example of the design for the ultra wideband. It's also square or zigzag, but you would put anchors very close to the corners of your walls in every location area. And we will have the 5th anchor for location error correction, which is very important. That's it. Was it 111 seconds? And now a very quick video of ultra wideband testing that we've done with Matt. We've also done similar tests with Jussi. There we go. So we are back to my house. I'm attaching a tag to my hairy head, very hairy actually. So I hope that the hair is not the heaviest attenuator in the world. There you go. That's your tag. And on the right-hand side, you can see the live calculation of our location from me and Matt. It's mad. It's like few centimeters really. And I think that was a nice evasion from me. I think it was set to 20 milliseconds, the frequency of a blink from an ultra wideband tag. Here you can see the difference in weight. So I didn't feel it. Matt has also almost collapsed. And you can see the events in the left top corner where we are changing, zones from the kitchen to entrance to cloaks. Or actually, I think it's called, the cloaks is called the max office. That's how Matt has named it. And we are there together. I'm not sure what we are doing. And that's the end of our test. That's it. There was no wayfinding paths. There was nothing drawn, no, virtual beacons, nothing. It was just the poor calculation of our,
And in that demo, because videos don't come across on GoToWebinar very well, but literally the frequency of the location updates is like many times per second as well. So if you want to learn more about ultra wideband, certainly reach out to these guys. Especially the ninjas have really done their homework. Josef, you've done some ultra wideband stuff as well, and also reach out to Sevio, who is our key ultra wideband partner here in Europe. SEWIO, Sevio.
They are amazing, but it's very important to mention here that the Sevio is integrating with Mist very nicely. So the main, it's not a competing technology. It's not. So BLE, it's in our phones. You don't require any specialized equipment for it. You have access points with BLE. You have phones. There we go. It works, but it will not work in like a construction, heavy metal, harsh environments where you have a lot of reflections. So Wi-Fi and BLE, it just won't work too well there. And ultra wideband is very good in this location. So you can have like a Mist deployment throughout the warehouse, including the offices, and then you can just connect you can connect ultra-wideband anchors to PoE pass-through ports of missed access points to have both BLE and ultra-wideband, and it's also very easy to work with.
Exactly, and the ultra-wideband requires a separate infrastructure again, but it can draw power from mist. And to summarize, like if you need sub-meter, like less than 1 meter accuracy, if you need like 10 updates per second, and if you have, especially if you have like difficult environments where let's say a factory floor, a warehouse, things like that, you need high accuracy, definitely go for ultra wideband. In other cases, like, you know, traditional corporate indoor, schools, healthcare, all this kind of stuff, enterprise offices, then BLE is probably the way to go.
Exactly.
But it all depends. So that's why trusted RTLS partners like these guys are very valuable for Mist.
Yeah, we didn't want to dive too deep into, like, you know, use cases and pros and cons of all these technologies because it's too complicated to cover in, like, you know, 3 days, not yet alone in 20 minutes.
Speaking of which, thank you so much, ninjas. I think we are slightly over time, which never has happened in these webinars, by the way. This is the first time we've ever been over time. So, should we let Yosef Graziano loose next? And Yosef, if you can be slightly faster than the ninjas, that would be much appreciated, so that we leave some time for no, that's not going to happen.
Jussi, I'm going to have to drop off to get back to work, but you just want to make sure that I'm not the organizer in case I close the webinar.
Okay, let me.
I passed the controls over to Yosef. Yosef, can you confirm that you are an organizer now?
I am, and I'm sharing my screen now, so please confirm that you see my PowerPoint at least.
Perfect.
We see, but it's not in full screen mode yet, but we see it. Let me take organizer rights from both. Oh, well, I guess I can't take organizer rights from you guys, or
you wait for us, Jussi.
Matthew,
well, I just want to say thanks for having me, Jussi. I'm going to drop off now, but thanks, guys. It's great to speak to you, and I'll see you again very soon.
All right, thank you so much, Matt. And sorry for the screw up earlier today.
No worries, mate. Don't worry.
Talk to you later, man.
Bye, mate.
Bye-bye. Thank you for staying on. All right, Dr. Graziano, by the way, is your text supposed to be centered? Because at least for me, it's not.
No, it's not. It's not supposed to be centered. It's not the idea behind putting it there.
All right.
It's supposed to be weird.
It's supposed to be weird. This is about Wi-Fi, right?
Yeah, this is it's never like quite there. Yeah.
No. So thank you very much, first of all, for having me here. And what I want to present today, just a little bit of our journey as Wayv, as my colleagues in the company, and the kind of transition that we are doing from being kind of network engineers, Wi-Fi engineers, into a new world of automation and making things more efficient a little bit. I won't be showing a lot of code, but hopefully I made some slides for you, Jussi, just to make you happy this time. Anyways, I hope I will add one slide later on with some resources, which is we can post them later on with the presentation. So what I want to give you first is the ways that you can make your Wi-Fi bad. Because if you know how you make your Wi-Fi bad, you can start taking care of fixing these problems before we get into automation, before we get into advanced services on top of the Wi-Fi. We need to tackle some points that we see a lot and on daily basis in the environment where we operate. So we operate a lot in warehouses and in manufacturing facilities. Unfortunately, I can't name my customers, but they are very large customers with multiple factories. They deal a lot with big machines, airplanes, autonomous robots, and things like these. And in these environments, you see slightly different environment than offices. You see offices for sure, but you see a lot of metals. So if if we are talking about 20 by 20 meter one machine or an airplane wing, this is a major effect or a major barrier to deliver good Wi-Fi. One of the things that we see a lot, we are in Germany, and this is something that we see a lot here. Many companies, they do contract with the electrician company, and the electrician guys, they install the access point. Actually, they design the access point. And what they do, we see a lot of cookie cutter. So when you take a map and you see the installation of the access point, you see every 10 or 15 meters, there's an access point installed. And it looks like someone took the map and just drew circles. And from that point, they say the Wi-Fi should work. So if you look inside your environment and you see that, it might not be the good deployment of Wi-Fi. So if you have some problems, you should start checking if the deployment that you have is covering your area. And sometimes we see they use wrong hardware. By saying wrong hardware, mainly I'm talking about antennas. Antennas are really, really, really important. So in office environment, we have mainly omnidirectional integrated antennas inside the access point, like the AP43 or AP41. You have a really nice antenna array inside it. That's good, but not good enough for environments where you don't necessarily need to put the signal everywhere in 360 degrees pattern, but you need to cover certain areas, sometimes only the aisle or between the aisles, or sometimes you need to cover only a corner of that area from that access point. So in order to do that, you need to have the correct antennas installed in your on your access point. So by default, we kind of say from our experience today, when we go to manufacturing facilities or warehouses, the best choice would be an access point with an external antenna plugs where you can change the antenna if you need it. So if you designed and the reality is not making your life easier when you deploy the access point and you find that that antenna is not good, you can just replace the antenna with a different pattern. One of the other points is default configuration. And I think you guys see that, that we see a lot of default configuration out there. It feels like someone plugged 1,000 access points and kept one RF profile for all these access points. It doesn't matter where, if they are offices, if they are workshop, if they are a factory. These, I would say, when we talk about RRM, this is one of the major failures that we see in RRM. So a lot of people don't trust RRM. However, if you configure RRM properly, it might work. Apologies. Yeah, and having a lot of access point deployed, sometimes we see some issues which is not directly related to the access points. We see some kind of missing VLANs on the switch port. This is a nice thing that was presented yesterday in the MIST bootcamp with the integration with Juniper switches, where you can, if you push an SSID with a different VLAN, that this VLAN, the VLAN doesn't exist on the switch, so you can have an alert on that VLAN doesn't exist on the switch. With the current manufacturers that we work with, we don't see this option. I mean, we start troubleshooting stuff, and then we had it last week, actually. We started replacing access points, and they said whenever we get to access point 13, we drop Wi-Fi coverage. And we started investigating, and we found out that the switch wasn't really configured to support the VLAN to terminate this SSID. But it's a lot of work to just go and dig deep and try to understand what's happening in order to find this issue and fix it. Yeah, bad security practices. This is a big thing. You can still, even today, we see WPA with TKIP, or I'm a big fan of limiting the access ports where you plug your access point, put some kind of at least MACsec, or if you want to be a little bit more sophisticated, you should have the access point authenticate into a Radius server and then unlock this port before you allow anyone to come and plug an access point and start broadcasting. So big credits for Sebastian, by the way. He's good on finding these pictures. And today we see a lot of trends that drive in this need of automating. So we do Wi-Fi in a traditional way, or we used to do Wi-Fi in a traditional way. We take the access points in the office because we also install these access points. So we kind of take them to the office and start staging these access points, put in the configuration on each one of these access points, working a lot with Excel files, and then go out and deploy these access points and fix the configuration. And we are a small company, and we are 15 people, and we start finding out that it's really hard to find also people to do this kind of work. On the other side, our customers are pushing to having these projects deliver faster. So we have a lot of Industry 4.0 transformation now. Everyone is going and talking about paperless projects. Let's use laptops, let's use tablets in the shop floor to follow on manufacturing processes. A lot of IoT devices coming in, and when they come usually in big amounts. And by IoT, I mean small sensors connected to Wi-Fi. It's not only big machines, but a lot of even temperature sensors that they send a message once every 2 hours. They still prefer to connect to Wi-Fi because it's a very cheap and very ubiquitous connection method. What is driving also us to do more automation today is the availability of API. So we are a company which dealing with different vendors, but I must say, after working with Mist API, it makes these things very, very, very simple to take them and deploy or configure access points in a very native way, because we kind of eliminate this kind of interface that we need to work with other vendors, that we don't have an interface to write to the controllers, we don't have an interface to write configuration to the switches. So we do a lot of copy paste and text files. We can manage that a little bit smarter today, and hopefully I see a big leap in that direction in the whole industry of Wi-Fi today. So one of the main tasks that we focus on, and this is true also for Wi-Fi, but also true for wired network, and I think true for every project that we approach, is collecting data. And collecting data is one of the crucial points. I think without collecting the right data, you can't go forward and you can't improve anything. By collecting data, you can learn what is the status of the network today. Do you have any open ports? Do you have free ports on the switches? Do you have enough power on the switches to support your planned 30 APs in that factory? And if you look at the wireless controller configuration, it is really important to collect this data and to put it in somehow in a method that you can use it later on. If you do some coding, I'm not a coder, by the way. We have a lot of smart guys, way smarter than me in the company, young guys that they do a lot of coding. You just bring the idea and they will code it. But on the other side, I really want to learn it myself. One of the things that I struggle with is regex. So if you start working with usual or normal Wi-Fi systems, you start parsing all this information or all these CLI commands that you put into the switch. You get an output, you take that output, and then you say, okay, how can I make that output look something that I can use it later. And one of the ways is we use a lot of regex to take these unstructured data, the big chunk of data from a text file, which is a configuration of a switch or a router or a controller, and now it's starting applying a logic on it that you break it down into parts and use it later on for your automation. So this is one of the points where we also can help us or help our customers to move from one vendor to another. At the moment that you have all this data, the configuration, and you structure it, it will be really easy to move to a different vendor and apply this configuration and using API and some kind of a Python script. What you see on screen, it's a lot of, we heavily dependent on Ansible for data collection and even some kind of configurations. So we use Ansible a lot. It's not perfect, but this is one of the most valuable automation tools that we use today in our day-to-day business.
Hey, Joseph, you have roughly 3 minutes. You think you can make it in that time?
Well, you said 20 minutes, you see.
Don't you? Aren't we roughly there?
Yeah, no worries. So, yeah. So we do, we need automation on different areas. And most importantly, as we see today, we need more automation on deployment validation. I think I skipped one slide. Yeah, sorry. We automate switch configuration, and in order to do that, we divide the switch into general configuration and port configuration. Mostly access points will be either trunk or access ports, and depends on your setup. But an access point port is different from client port, and it's different from trunk port. So what we try to do is dividing the switch configuration, for example, into multiple parts and applying these parts further on the new equipment. You also need some kind of automation in validating this deployment. So we do validation site surveys, but sometimes you need to figure out that how much power budget you use from your switch. Is these RSSI values that you are collecting are what you expect to collect? And do you need to tweak your RF profiles in order to fix your, or after the validation survey? Documentation is one of the big things. I don't know about you guys, but I think many people hate documentation. You finish the project and everything is done, you deliver everything, and you still need to finish the documentation, and this can take sometimes weeks to write down everything. Automation is there to help you on documenting all what you've done. So if you collected these data that I just said at the beginning, you have already most of these data. You just need to put it in a CSV or a spreadsheet and make it look nicely, and then you deliver it to your customer in 0 time almost. You have all the configuration documented, and you have the inventory status. So automation is actually helping us a lot today on documenting and delivering the projects faster. Yeah, what can't we automate today is design. So design, actually, it's one of the tasks that consume a lot of time, and rightly so. You need to think very carefully about the design that you build, and you need to test it in multiple iterations. Especially in this kind of environment, it looks very dense, and we have a lot of metal over there. So sometimes we take this hybrid approach of design, but it's not one iteration of design is enough. We need to do multiple iterations of design in order to get to the results that we need. This we can't automate today. Thank you very much, Jussi, and thank you very much, everyone.
Thank you very much, Mr. Graziano. We will take questions also for Yosef at the end. Now, Jonas, how are you doing in that fancy hoodie of yours? Ready to present?
Yes, I'm totally ready.
All right, all right. And if you can, please save some time for Francois understand you have the content, so don't skip any of the valuable content either. And just a word for the audience: we reserved 90 minutes for this time, and again we're gonna run over. So I apologize in advance.
I will try to save some time.
All right. Thank you, Jonas, for coming on. And we see your screen now, but it's in presenter mode, so you may need to.
Can you see my PowerPoint or not?
It's on presenter mode, so we can see your presenter slide. So if you go on, and change the display settings for.
How do I change it?
Put it back. Put it back in full screen mode, or the previous. There's a Vergrave inställningen at the top of the screen.
Where? I'm sorry.
That one. Click that, and then swap displays is what you want to get. Here we go.
Okay. Thank you, Jussi, for the help. So I'm Jonas Dekkers from Wayv. We try to create some awesome things with APIs. You don't going to see any code. We just made a nice user interface for our solutions. We try to create some secure ways to onboard your visitors and also your employees. These are the founders of Wayv. My colleague Hans Mathé is also CWNE. I'm only CWNA. We are both from Belgium. It started as a hobby to try some APIs, and now we have a full cloud-based solution with a lot of products. So I will show them right away. So why we like Mist? Just like Mist, we are fully cloud-based. We like the API first approach. I think it's we also like the feature, the unique PSKs from Mist. Yes, we use the APIs. Our solution is fully multi-tenant, so distributors can create resellers, resellers can create customers. I will show it right away. And we also make use of QR codes for easy onboarding. So you can create QR codes for unique PSKs, so you can easily onboard everyone. So the first solution I wanted to show you is the multi-PSK manager. We created it especially for Mist. I'm just going to show that because he's automatically jumping to the next slide. But I will do the demo. So I will share you my browser. So the unique PSK feature of Mist is a little bit hidden. So if you want to use the unique PSKs, you must you must click on more options, and then you can click multiple phrases. It is possible to use different VLANs for it. So I'm going first to start with what are the advantages of multiple passphrases. Multiple passphrases, for example, at home, you have one passphrase for everyone. But at the company, you can use a passphrase for everyone or for every IoT device, and etc. And one nice feature is that you also can define VLANs to it. The problem at the moment with the Mist dashboard is you can't assign a VLAN by the Mist dashboard, and also you can't create them in bulk. So what we create is a Mist UPSK manager. So this is our dashboard, our Mist, our Wayv dashboard, and here you can create your PSKs. For example, test. And you can say for which network you want to create it, and here you see you have the option to assign a VLAN to it. You can also assign a MAC address and etc. But at the moment, I'm just going to create a password to the VLAN. So that's very helpful if you want to onboard IoT devices. We also created a bulk import. So, for example, I've just created a CSV file with 6 passwords or so on, but someone from Mist tested it with 5,000 passwords. So you can easily create 5,000 unique PSKs that you can use for your IoT or your employees or etc. So you see, you don't see any API code, but it's all done by our system. And now they are all created. I'm just gonna submit. So this is a free module. You can just use it. So it's easy to create multiple passwords. You can create VLANs to it. You can download the CSV. You also can show passwords. For example, we created some passwords for Bob Friday. His old password is DVD player. At the moment, it's the Netflix of the Wi-Fi. So that's everyone who is following Twitter will understand that. So that was our first solution. As already mentioned, it's totally free. It's ideal for IoT devices. Then the second solution we have, it's our solution to onboard your employees. So our previous solution is great for creating in bulk unique PSKs, but it's difficult to keep them in sync. For example, some employee is leaving the company, you must manually delete the password. So to prevent that, we created a solution, and we create an integration with Microsoft Azure, Office 365, or G Suite. It's a light NAC solution. So you can easily create an onboarding solution where employees can onboard themselves and get a unique PSK in the right VLAN. So you can assign, for example, you can say the marketing department needs VLAN 20, the directors need VLAN 40, and they can just get their own unique PSK. And if they leave the company, then we just delete it. So I will show it how easily you can do it. So here you have the Azure integration. So first of all, you need to link with Azure. There's a documentation for that. I think it takes 10 minutes or something. And then you have a full integration with Azure. And the cool thing what you can do then is you can, for example, for a school, you can say if a teacher log in with Azure or Office 365, you can link them to VLAN 20. If someone from the administration is logging in, you can assign VLAN 30, and the students may not log in on the Wi-Fi, so we say block. So you see, I think it took me 1 minute to create a full workflow to onboarding, and now I want to show you how it's working. So you can share this URL on your internal site or something, or you can create an OpenSSID where you have a captive portal where this portal will be displayed, and then the employees can onboard themselves. So I'm going to just use a teacher demo account. And what we do then is we create a unique password for that teacher. And you can see that we assigned VLAN 20 to it. And now if I will refresh, You will see the Bob Fridays users are automatically created by our system, but also the teacher demo. And if this user will leave the company, you automatically delete the password. So all the unique PSKs keep in sync. You don't need any radius or an expensive cloud radius solution. You can just onboard your users very easily with our solution. We have the same solution for G Suite. So it's very slick. We see more and more companies moving to the cloud. They don't have any server in-house or a radio server. So you can just use our cloud platform. So you don't need any radio server, and you can automatically onboard everyone. So I really like this product of us. Then for the visitors, we have a full visitor registration platform. It's running on a tablet, so you can set it on the reception. You can say I'm visiting person X. Person X will receive an SMS, an email that this visitor is in a house. You have an overview when there's a fire evacuation or something. You can have an overview in our system, how many visitors there are today, how many there are already out, how many there are still inside. Here you have a list of the current visitors. It's also multi-tenant, so you can manage all your customers. It's just by switching. Now I'm on the account from Kappa Data. You can just go back. So it's very easy cloud platform with different solutions. But I don't think I have time to fully demo it. So then we also have another solution for the visitors. It's just a one-click solution. So you can also run it on a tablet. You can click on a button and it will generate a unique PSK password. You can also print a badge. I'll show it if you want. So how it's working. You also see it here. And this will generate a unique PSK, also a QR code. So if your visitors are there, they can just scan in the QR code, and for their laptop, they can just take the print out, so they can onboard securely on the Wi-Fi. Golly, come on. Then coming soon. So we are also
on that previous thing. Can you show like your LinkedIn QR code to it so that it would read actually the information like my first name and last name and whatever directly from my LinkedIn QR code, so you wouldn't need to type them in?
We are working on a solution. You mean for the visitor registration part, Jussi, or?
Yeah. So there would be like a camera or something that would just read the barcode of the LinkedIn or the LinkedIn barcode that I show on my phone, and then it would automatically retrieve my name and contact details, whatever.
That's a good idea. At the moment, it's not possible, but we are working on a solution that we can send a QR code based on a meeting request. So we can read out the meeting request if you add us at our email address in CC, and we can send a QR code to all the visitors that will come to our office, and then they can just scan in the QR code and you're automatically onboarded. That's the thing where we are working on, but the LinkedIn QR code I never thought about, but we can do that. It's a good idea. I will take it into account. Thanks a lot.
Absolutely. Hey, by the way, we need to let Francois loose at some point as well. Also, Francois, are you okay to go over a little bit? I know the audience usually is.
Yeah, it's fine. I'm good.
Okay. Do I have 2 minutes, Jussi, or?
Yes, sir.
Okay, so which solution are coming soon? It's our Flex Office Rooms solution. It's a LAN and WLAN solution. So you can create rooms, and you can assign LAN ports to it, so switch ports to it, for example, in student rooms. And if you assign that to a person, we assign a unique VLAN for every person or company, and you can assign rooms to that visitor and or company, and we automatically change the switch port to the right VLAN. We create a unique Wi-Fi password for that person in this VLAN, so he have his own network. So it's very useful in healthcare, at student rooms, all that kind of stuff. We are also working on a hotel solution where we create a unique PSK that's linked to the hotel room. We have created an integration with different PMS software. So if a visitor checks in, we automatically create a unique PSK in the same VLAN as a hotel room. So we can just come in his hotel room and he can just stream Netflix and all that kind of stuff. So voila, that was it. I just want to add this promotion. So for all the webinar attendees, all the partners, we offering 1 year free WiFlex subscription, so you can test our solution. For all the customers that are watching, you can get a 20% discount over the first year. You can register yourself on that URL or scanning in the QR code. So that was my presentation. I hope I was clear. So thanks a lot, Jussi, for having me.
Thank you so much, Jonas, and a great presentation. And this is like such a great example of like NIST needs to focus on making kick-ass Wi-Fi, but we can't do all the apps that are customer facing. And that's exactly like the point where true value-added resellers stand, and you know, you guys are the interface between the customer, translate the customer requirements, you understand our system, and then you create value-added magic, and not just push boxes. So not to take any credit from box moving as well, but this is very, very cool.
Thanks a lot,
Mr. Francois. Are you the Francois?
Yeah, I'm here. So
Excellent.
Am I the presenter now?
I think you are. Are you? You should be. I will make you presenter one more time. Okay.
I am.
Should have them both.
Yes, now I can. All right, so I'm gonna show my screen. Can you guys see that?
We can.
What if I play it? Nice. Okay, so I don't have a lot of slides. I wanted to spend more time doing the demo. This is just, you know, what we're going to talk about today: Python API automation. I haven't done as much as Jonas has done. Obviously, I'm just, you know, starting playing around with the Mist API, but I've been really enjoying it lately, and I wanted to share a couple of stuff with you guys. So hopefully you can get started on your end. This is just about me. I think I've already talked about myself. Here I put a couple of websites that could be interesting for this presentation, especially the GitHub, where I'm going to be sharing one of the scripts I've done, and you guys can go ahead and use it for yourself. And I started to do some YouTube videos as well, where I go and explain, you know, how everything works related to the Mist APIs in a little bit more details than, you know, what I'll do today. So if you guys are interested, you can go ahead and check that out. So today, what I want to do today is two demos. The first one will be to showcase how easy it is to just set up one API call within a Python script, right? So we'll do a little bit of code. I've never done a live code demo, so hopefully, you know, everything will go well. And then what we'll do is we will create a simple script that will list all the SSID part of a Mist site. Okay, so we'll do that together. And the second demo is one script I've created to automate the process of configuring an AP before an AP on a stick site survey. So that's something that, you know, with other vendors, you usually do it the night before a survey. And if something goes wrong, you end up you can spend, you know, hours trying to make it work. And so I wanted to see if I could automate that process with the Mist API. So now we'll see how long it takes if we can just automate that process. Okay, sounds good. So let's get into the demo time, right? What could go wrong?
The answer is nothing.
Nothing, right? Okay, so can you still see my screen?
We can, yeah.
Okay, so here I'm gonna juggle in between my browser where I'm connected to my Mist dashboard, and then I also have a terminal, right? I'm gonna increase the size a little bit. I have my terminal where I'll be running the script in, and then I have a text editor or code editor, name it as you want, where we'll be writing the code in, okay? So the first script we want to do is actually, create a simple API call to list all the SSIDs part of a Mist site. So here I have my dashboard. If I go to my organization here, under site configuration, I only have one site. It's a primary site. And within that specific site, if I go to network WLANs, you can see that I have a whole bunch of SSIDs that I've created, right? So it's essentially the script will do, the script will just list those SSIDs, right? So let's see how we can do this using APIs. The first thing you want to do is you want to go to the API documentation. So to get to the API documentation from the dashboard, what I do is I go to the help icon, you click on the help icon, and then you get access to the API documentation, right? You can see it's a very fancy website, but you have a lot of good information in here. For the call we want to make and list all the WLANs, we have to go under the WLAN section here. And then here we will get all the information we need to make the API call. One important piece of information is the URL that we'll need to send to retrieve those sites. And here you can see that we're going to have to include that into our URL. And Mist shows you an example of the data you will get back from the Mist cloud when you're asking the cloud to send you that list of specific SSIDs. So it's sending you all the WLAN profiles, and then it's sending you a pair of key and value that would detail anything regarding that WLAN profile, right? So we can see the SSID and so on. We have a whole bunch of other information as well. So now if we want to create a script, a Python script, and make that API call, what do we need? So I need to create a file. So I have my demo one here. I'm going to new file, and I'm going to call it a new Python script, I guess. I'm going to call it list.wlans.py. And in order to make this work, we'll need to import two libraries. The first one is called requests, and that's the library we will need to actually make the API call. And the second one we'll need is the JSON library, and we will need this library to understand the data that the Mist cloud is sending us back, okay? Then in order to make our API call, we need to build our API URL, right? And in this specific case, we need to send a GET request because we're pretty much just asking the cloud to send us some information. So we're not doing any changes or anything like that. So we just need to send a GET request. And then to specify, and then the URL that we actually need, if I go back to my Mist documentation, is actually this guy here. So I can copy and paste this one. And before that, I need to put the address of the api.mist.com, right? So that's the URL I would need to send if I want to retrieve the list of WLANs, okay? So what I do here usually is I define one variable for that specific URL. So I can go back and copy paste this guy here. And here, as you can see, we're gonna have to specify the site ID, right? And if you want to find out what your site ID is, you can go back to the Mist dashboard, and usually I go back to the network and WLAN list. Make sure you have the site selected here, and then in the URL here at the top, anything that's after the last slash will be your site ID. So I can copy this guy and I can paste it here, and now I have my URL. Second piece of content I need will be the header. So along with the URL, you have to send a little bit more information. And in this case, when we're dealing with Mist APIs, we have to specify two types of information. The first one would be the content type. So this is the type of data you're expecting to get back, or you're expecting to send alongside your API call. And in this case with Mist, we're using JSON. So this is going to be application/JSON. And we also have to define the authorization method we use in this case, to authorize our case ourselves to send that API call to the Mist cloud. And in this case, we use a token. And so I'm just going to specify a token variable at the top here. I'm not explaining the Python code, but if you watch the YouTube videos I've made, I actually go and explain the Python code. But so here, what I'm doing is later on I will go and get a token. Token is a private information, right? And this token allows you to actually send API calls to the Mist cloud, right? And this is what we'll send along our URL to pretty much make everything happen. Then I need to make my call, right? And to make the call, we're going to use the requests module, and we're going to use the get function within that request module. And what do we need to pass as an argument? Well, we need to pass the URL and the headers that we've just defined. Okay, so here, this will actually send the call, right? And then what we need to do is we need to put in a variable all of the data we get back from the Mist cloud. So here I'm just going to define a variable called get response, and then in that variable I will get all the response, all the data that the Mist cloud will send back to me, and part of that data will be hopefully the list of WLANs. Okay. And then here, what I can do at this point is I can understand. I'll try to get access to that data. One thing I like to do is check if everything went well, and you can do that using this get response.status code. It's going to give you the status code of that specific API call. Mist is using a RESTful API, which is based on HTTP, HTTPS. So you'll see that the codes are, HTTP codes. So 200 means everything was good, everything went well. So if everything went well, here we'll be able to actually, get access to all of the data. And then else, I'm just going to create the else right now. And if something went wrong, I can, print some message. I can say something went wrong, and then I can display the error message. I can display the status code, so we can investigate what went wrong. Okay, so assuming everything went well, and I hope everything went well, will go well in this demo, hopefully. What we can do is we can actually retrieve the data, the JSON data that Mist is sending us back, and that JSON data is actually into a variable called response .text, right? And then what I can do here is I can convert that JSON data into a Python dictionary, so it's easier for us to handle the data within our Python script. And to do that, I'm just going to define a new variable. I'm going to call it WLANs, and then I can do JSON. I'm going to use the JSON module that I've just imported at the top, and then I'm going to load. I'm going to use the loads function, and here I'm going to put the get response .text. Okay, and so this will convert the JSON that I'm receiving back from the Mist cloud into a Python dictionary, and then here from there I can do a loop. So I can do for WLAN in WLAN. So I'm going to loop on all of my SSIDs, and here I can print the name. So I could print. I'm actually going to print the ID as well. So I can do WLAN, and then I can go and retrieve the value corresponding to the ID key, and then I can print the SSID. Same way here, I'm going to retrieve the data corresponding to the SSID key, and then just for fun, we'll do the band, right? So this will tell me on which band that SSID is defined on, right? And then hopefully this will do it, right? So this is all the code you need to send one API call. In our case, it's a get. So we're getting information from the Mist dashboard. And here, the last piece I need to do is actually go and get my token. Okay, so token is private information. So I'm just going to copy paste it here out of sight. Right, and then I can just save my script. And so here, if I go back to, can you guys hear me still? Are you still following me?
Loud and clear. Loud and clear.
Okay.
And we are following you. This is really good stuff.
Awesome.
It's almost
okay.
like Ryan's and Jake's course in 10 minutes.
Yeah, no, that wouldn't be that pretentious, but anyway, so here if I go to my directory, my demo one, I have my Python script here, and now I can run it, right? On my computer, I use the Python 8, and so here I could just do Python 8 and then launch a script, and here it's not going to work, right? So here it's not going to work because we need to install the request module, right? I haven't installed it on my system. And so here I could totally install the request module on my system and I'll be able to use it. But what I actually like to do when I work on different Python scripts is I like to create a virtual environment, which is pretty much going to create an environment in which I'm going to be able to install whichever modules I need for that specific project. Okay, so I'm not going to go too much in details on how that works, but I will use the Python version that I want to use, and then I can do -m virtual environment, and then I can call it Mist demo, the name it just yours to choose. And then once you have this virtual environment created using Python, whichever version you need, here I can activate that virtual environment. So I do source Mist demo bin activate, and here you see on the left, I'm into that specific virtual environment. And if I look at which version of Python I'm using whichever version I specified here while creating my virtual environment. So in here, it's a brand new virtual environment. So obviously I don't have the request module yet, so I can go ahead and install it. So I can just use the pip install requests command, and this will install the request module. And from there, I should be ready to test our script. So I can just do Python list wm.py, and it worked. I'm very happy it worked. Okay, so this is the list of all the SSIDs we had in the dashboard, and as you can see, I'm getting the ID, the name, and the band, right? All of this in one API call. I could get more data out of these SSIDs if I go to the API call, and if I look at all the different keys that I have access to, I could find out if the SSID is enabled, what type of authentication, you name it. The goal of this little demo was just to show you that it doesn't take a lot of line of codes to actually create an API within Python and integrate it within your script. Okay. How was that? Good.
Sweet.
Fantastic.
Yeah, you went quickly, but you were explaining really well along the way. Plus, you got it to work.
Yeah, I'm happy it worked. Yeah, I know. I went quickly. So if you have no Python experience, maybe that was just gibberish to you. But hopefully, if you have a little bit of programming experience, hopefully this made sense, and maybe can inspire you to try it on your end.
Absolutely, and we are all nerds here. And do you have any like further reading? I know if you go to conferences like Wireless LAN Professionals Conference, they usually have this 3-day Python boot camp actually on their selection, for example, which is hosted by Mist employees actually, Ryan Azima and Jake Snyder. So that's a really good place to start during the conferences. And of course, what are your favorite places online, Francois, for example? Where did you learn? How did you learn to do all this?
So I learned actually when I went to WPC a couple years back, I attended that specific boot camp, and then I got a book from Jake and Ryan, and it was Learn Python the Hard Way. And they would give you a couple of scripts. Yeah, this guy exactly. Yeah. So I used that book, and then I have when I went to university. Yeah, I don't know this one, but the Learn the Hard Way is the one I used. And when I went to university, I actually did a lot of programming back then. I did a lot of, we started with like assembly code, and then we did C, C++, Java, you name it. So I knew what a variable was, the integer, and all of that. So I wasn't starting from scratch. I just needed to learn about the syntax and get back into the coding mode, because I actually studied networking because I didn't like coding too much. Right, but now that I can see that I can apply code to something that I like, Wi-Fi, it's very exciting, and I guess I can use those skills that I've gathered at studying at the university So yeah, so I wasn't starting from scratch, but I used the book to get used with the syntax. And then I did a lot of YouTube, like I learned from YouTube, right? So I watch a video and try to see how they do things. One thing that I did, if you ask, I mean, I guess I can show you what I've done is if you go on YouTube, on my channels, if it works, actually it came up with a couple of videos to explain you know, how I do my stuff. So I did one where you can set up your first API call, and this is more using Postman, which is not coding, it's more an application that helps you to get familiar with APIs, and then one within a Python script, and then how to set up your virtual environment. Kind of like what I did really quickly. I explained it here in 15 minutes. So if you want to get more data, you can watch these. They'll help you out. And then Mist has a good class on API, right? Is it class.mist.com? I think that's a
api-class.mist.com, I think.
Okay, so this API.class.mist.com. This is I didn't know about this guy. I just learned about it yesterday watching the bootcamp, but I've taken a look at it and it's really good. So
good stuff,
yeah,
good stuff. And then
anyway, let me get into.
Yeah, go ahead.
Do I have time for my second demo? It involves. Let's find out. No, 5 minutes.
Sounds good to me. Let's find out.
Okay, so I have a Mist API here connected to my internet, right? So it's just a Mist API. I've taken it outside of the box. It hasn't been claimed to anything yet, right? And I want to configure it to do my API on the stick site survey, right? So I've actually, I'm going to go to demo 2. I've actually created a script for that. So right now I have nothing, but I can go ahead and retrieve the one I have on my GitHub. And the way you do this, if you're curious, you go here to download, you copy that URL, and then you can go back here and you can say git clone, and then you paste that URL. And now I have everything here. So I can, I'm going to go a little fast here, but I can navigate into the directory where I have my setup API script. And all I have to do here is configure, actually give the script a couple of configurations. And so here I can actually go back to my, I'm going to go here. I'm going to go back to this. Tell me if you can see the editor.
We can, yeah. So when you configure a Mist API to an API on a stick survey mode, what do you do for the API? What are you going to show the configuration for that? Perfect.
Yeah, so what I do within the script is I create a site, right? And so if I go back to the Mist dashboard, it will be under organization site. And the reason why I create a site is because in order to have the configuration, stick to the AP itself and work without the access to the internet, you have to specify a settings under the site, which is all the way at the bottom here, called AP config persistence. So that's going to be very important for AP on the stick because the AP will not be connected to the internet when you do your survey. So you want to make sure that this option is enabled, and that's why I just created a site that has this this feature enabled right away automatically. And then after that, within that site, I will go ahead and create 2 SSID, one for 2.4, one for 5 gigahertz. That's just how I like to do things. And then I will claim the AP if the AP has not been claimed to the organization, so I can actually see it into the inventory here. And then I will assign that AP to the site that I've just created. And then when you do that, the AP will retrieve the configuration, start broadcasting the SSID. And the last thing I do is configure the radios. So configure the channel and the transmit power. Make sense?
Perfect.
So all of that within the same script, right? And so if I look at my config file, I have to configure all of that data, right? So the first section here is anything related to the API. And I will need to gather to get my org ID. So to get the org ID, if I go back to the dashboard, it's very simple. It's in the URL here. It says org ID. So I'm just going to copy and paste it here. And you're going to have to do the same on your end if you want to use this token. I'm going to go and put the token later on. Then for the site here, I've just defined the name of the site location. What's important is the country code, because it will change how the radio will get configured to make sure you don't go over your regulations. And then I configure my 2.4 information, name of the SSID, channel. Let's change it to channel 1. Power, we're gonna make it let's say 10. 5 gigahertz, same thing here. I'm gonna use let's say 36, and I'll use a transmit power of 14 is good. Okay, and then I need to give the details about the AP. So I need to give the MAC address of the AP. And if you don't have that information, you can just look at the back of the AP and you should have the information. So I'm just going to copy paste what I have here. And then you have to put the claim code. If the AP hasn't been claimed to your organization, you have to put the claim code. Okay, the claim code and the token ID are private informations. So once again, I'll go and ahead and do that off screen. I'm just right now I'm copy pasting the claim code to the config file, and the claim code, once again, it's on a sticker at the back of the AP, and then the token ID, I'm just copy pasting it, and then I'm pasting it to my config file, right? And then we're gonna pray the demo gods that everything will go well. I'm gonna hide this and I'll show you what I have. Okay, so if I go back here, this is what I have. I've actually hidden the API, but this is anything I need to make my API calls, my set config, my 2SSID, my radio configs, and then I've saved this file. So now I can go back to my terminal, right? And here I should be able to launch a script. So now for this script, you will also need the request module, but because I'm already inside my virtual environment, I should already have it in there. So now I can just, execute the script. And now I forget the name of it, setup. Okay, so Python setup AP on a stick, and then I have to put as an argument here, I'll put my config file. Okay, and so here I have my AP next to me connected to the internet, and then I run this, and it's gonna, hopefully everything will go well. So here it's created the AP on the stick site, it created the 2.4 SSID, created a 5 gig SSID, it claimed the AP to the organization, it assigned the AP to the site, and it configured the 2.4 and 5 gigahertz radio, right? And it took 6.6 seconds, okay? And that's it. Now you can unplug the AP, go on site, connect it to PoE battery, and it should be broadcasting those two SSID. If I go back, circle back, and go back to my MIST dashboard, and if I go to site configuration, now I have my AP on the stick, new site. At the bottom, I can see that the AP config persistence is enabled. If I go to network WLANs and I select here I actually have to refresh the thing, and I select the AP on the stick site, I can see I have my 2.4 5 gigahertz SSID. Here I'm not doing anything fancy with authentication here, because what I care about when I do AP on the stick is just the beacon that's sent by the AP. So I actually don't care if no authentication is configured here. And then if I go to the access point, under that site, I see my access point. So here it's disconnected. It takes a little while for the AP to get configured. As you can see, just refreshed here. I can see my channel, my transmit power on both 2.4 and 5 gigahertz. If you don't have access to this information on your dashboard, you can click on the settings here and you can select whatever you want, and you can reorganize, the different columns. Very useful feature. So here, if I refresh, I'm pretty much sure it's going to be connected. Now it's connected. I have the name of the AP that I've defined in my config. I have the channel transmit power I have configured in my config, and everything is ready to go. If I do Wi-Fi Explorer and I try to see, if I filter on survey, now I can see, I can see my 2 SSIDs, so I'm pretty much ready to go.
Beautiful, beautiful.
Questions?
And with that, questions for anyone in the audience? That was fantastic, Frank. So I don't know how you were able to cram like quick stuff yet understandable stuff in there so much, but this was fantastic. And combining all of these presentations today, it's like real world meets presentation. So it's been really good.
I was going to say, like, in the real world, sometimes you may want to change those settings, right? So all you have to do really is go back to your config and change it. So let's say we're going to go on 11 and maybe 8 dBm. This is in dBm. And maybe we want to use 44 with the 40 megahertz wide channels, you know. Maybe we want to change that to 9. I'm just using arbitrary stuff. I can save that config file and then I can rerun the script. And then here it will, the script will check if the sites already exist and all. It will not recreate it. It will just reuse whatever exists, and it will only change the radio settings here. So yeah.
Here's a question for you, for all of you. Shouldn't actually a MIST AP taken out of the box, shouldn't it run a firmware that would do an APOS setup by default that you could probably then control with the MIST app? So you could control the transmit power and channels and things like that for the AP directly from there, but it should come pre-configured for APOS operation. Let's say like really quick beaconing and of course broadcasting SSID stuff like that. Some good default transmit powers for both, and then you could adjust those using the app. How much? Because I mean, you shouldn't need to have a script like this ideally. That's a missed problem we that we should solve by shipping an AP out of the box with an access point on a stick configuration.
Maybe you would have to have like I guess an organization that you dedicate for that, or not sure. I'm not sure how that would work.
I mean, do you though? I mean, if it was running in a specific APOS mode, so it didn't need anything in the cloud, it would just beacon with specific settings, that kind of stuff.
I see what you mean. Yeah, you could totally do it. Yeah, it depends. I guess it depends on your customer and the use case. Like what's the first use case for the AP when it's out of the box? Is it to do an AP on a site survey, or is it to install on site? I guess that's going to matter as well.
Yeah, but I mean, once you connect anything to the AP, it should fall back, get out of the APOS mode, and continue its life some other way. But if you just power it up, for example, or something like that, then it would do APOS.
So there's other APs are doing that, and honestly, the first thing we do, we put them in that profile, which turn off all the radios, because we don't want to. If you go into do staging in the customer site and you have 100 access points connected to switches, you don't want them to connect right away to the controller and start broadcasting USSID and do the channel planning. So actually, I'm on the side who preferring don't do that. And I mean, for this use case, you can just come and configure the access point.
Okay, fair enough. Yeah,
not to allow these access points start broadcasting a default SSID when you just plug them into a PoE switch.
Fair enough. I'm buying that argument totally. Hey guys, we are only 30 minutes over at this point. Ilpo, Tommy, do we have any repeating questions or anything that should be covered here, or have you been handling everything on the chat and questions board, or how has it been going behind the scenes?
I think it's been pretty smooth here. Let me see if we have anything unanswered. Anders is commenting, it wasn't a boot camp, it was a sneaker camp, according to the picture you showed. And some other pretty good intro from France, 4 keys, 3. I think we pretty much covered it all.
Yeah, I think so too. But thank you so much for covering everything. And I'm already seeing on Twitter as well, like Keith Parsons just retweeted part of Yosef's presentation about, cookie cutter doesn't work and all that kind of stuff. So there's definitely activity on the questions board, on Twitter, and certainly here. Any closing words, anyone? What should people do next to learn more about like where Wi-Fi actually is going, other than our webinar tomorrow, which is called Game Over Wi-Fi said 5G. So if you haven't signed up for it, then you better. Google Game Over 5G, no, Game Over Wi-Fi said 5G missed, and you will find access to the webinar. And there will have Dean Bubbly, who's been also here talking on our episode 1, but it will be more 5G related. And he will also do 5G in 500 seconds. You better listen to it. Where else should people go to learn more about how can people be better Wi-Fi engineers in 2022? Let's start with Jonas. What's the one thing people should do better in 2022?
I think CWNP is a good way to do. So study for the CWNA, because we see a lot of companies doing it wrong, the site surveying and the configuration of access points. So I think that's a good point. I think that's
Absolutely.
one of the most important ones.
Absolutely, and you have your NA already.
Yes, indeed. And if you don't know anything about Wi-Fi, partner with another company that know how it's working. So I think that's a good tip.
That's a good point. And speaking of courses, I never told anybody this, so be quiet. But MIST will be coming out with a super nice 4-day course that will be made by industry's absolute finest. So stay tuned for that as well. I never said that. Francois, what do you think people should know come 2022?
I think that we should definitely learn how to code a little bit, or at least do simple scripts. But not forgetting that our core knowledge has to stay as a network. So if someone is just starting to be a network engineer today, or a Wi-Fi network engineer, they need to get their fundamentals solid. So they need to make sure they understand the network piece of it, and then build on top of that and learn some scripting languages, the stuff Yosef and Jonas was talking about, the APIs. I think I can see it's gonna help us to do our job in a more efficient way, and also with less errors. When I started working, I remember my first job, I got introduced to like a team of network engineer, and then the guy was like introducing me to the team, and he was like, okay, this guy, he brought the network down on that day. This guy, he brought the network down on that date, and all of that, just to showcase that we're going to make mistake and it's okay and all of that. But I think we can avoid that in the future if we're careful, and if we can leverage some of the automation and be more efficient in how we work, all across the board. So including documentation. I like what Joseph said about that. So I think it's going to be a good skill to have in the future.
Absolutely. Mac Dering, what do you think?
I would just say to stay curious and get your hands dirty. I think like having a home lab and proof of concepts in your lab, this is the best way to learn. Of course, on top of attending MIST webinars, but nothing better than hands-on experience.
I will give you $20 later.
Thank you.
Mark is very good at standing still, I have to say.
Yeah, I was looking at that photo like for the last half an hour.
Yeah, my camera has worked. 1 second. It's not working yet.
No, it's fine. We like you look very artistic and photogenic in the picture, so
Indeed.
Thanks.
Yosef Graziano, what do you think is the #1 thing people need to know about networking come the year 2022?
2022. I used to say you need to have a solid understanding of networking, security, and Wi-Fi, and even for entry level. And while you master that, today I would add Python on top of that. So you need to have these 4 domains to be a good Wi-Fi engineer, and also to secure job for the future and to develop yourself.
Perfect. Hard to disagree with that. With that, I would like to thank all the presenters and apologize to you guys. We went over time again. significantly. I will certainly try to improve my act so that, you know, you could get back to work. Same with the attendees. Thank you so much. Sorry we ran over time. Thank you, Jonas. Thank you, Francois. Thank you, Joseph. Thank you, Mac and Matt. Great presentation.
Thank you very much.
Really solid hands-on advice from all of you. I see Twitter has also lit up because of you guys. So thank you. And until the next part of Nordic Wi-Fi.
See you next time.
Thank you.
Thank you very much for having me.
Nice day.
Thank you.
Nice day, guys.
See you guys.
Thank you so much. Thank you.